my research paper, it's selected research the non-zero sum game of steganography in heterogeneous environment. So I like to divide it in three parts here, so to understand better. So one is steganography. So steganography is basically hide messages inside cover objects. In real life, cover images come from the variety of devices pipelines, like can be a camera, smartphone, different settings like ISOs, different processing pipelines like that. So non-zero sum game is where the gain of one player is not necessarily uh, the loss of the other. That means when it comes to the zero sum game, it can be win loss scenarios. In here can be win and lose scenarios. So heterogeneous environment is a multiple environment that real world settings images come from many sources, different cameras, pipelines, ISO, etc. The overview of this paper, the authors reframes the steganography and technologies as a non-zero sum game. Models heterogeneous environment, like I explained, need the multiple that it can be multiple image sources. The proposes two solutions here. The one is double oracle algorithm. Other one is min restricted classifier. What is the double oracle algorithm? Is the attacker defender keeps setting best responses until equilibrium is reached. Very accurate but computationally heavy. Other one is the fast approximation method that rewrites the minimize the regret. Strength here. So I invite four strengths summarization here. The one is realism. It's a paper assumes the attack act rationally and pick sources from help them other hide better. Game major thing is the game theoretic creature that it use solid mathematics to model their attack defend the interaction as a game. Practical contribution here is two solutions here provided. One is double oracle, that is for the more accurate, the mean retreat, the efficient. The both theory and practices are addressed here. Experiment evidence tested with real image datasets. Alaska. Weaknesses identified, that idealized assumptions here, that both attackers and the defenders are perfectly rational and know everything about the environment, not always realistic. Narrow scope, only the tested with one steganography method. It's called JMI prod. Other one is efficient net B3. The results may not generalize to other techniques. Computational cost. Other reason computational cost is a double oracle. When double oracle requires training many deep networks repeatedly, which impact the outside research lab. Metric focuses, it's the focus mainly probability of error, but in the real world the false positive can be more damaging if too frequent. Opportunities here that the future use, the one is relaxed assumptions. Under that, the bounded rational, the model attackers with the limited knowledge or resources, more realistic method. Extend view images that used can be multimodal steganography, extend each from images to the media like video, audio, text. But experience to try to more algorithms, payload sizes, and adaptive attackers. Scalability, improve methods so that work when there are hundreds of cover sources, as in the real world platforms like Facebook and Instagram. And here the last one, the opportunity like online learning and cyber threat intelligence, adaptive systems that like from new data continuous and integrating with security terms. Conclusion here that major contribution is frameworks that realistic model adaptive the attackers and heterogeneous environment. Key messages here to present the current holistic detectors and vulnerable. We need adaptive game aware strategies. Limitations ISO that high computational demands and idealized assumptions. When it comes to the impact, the set of foundations for the new generalization and resilient strategy aware technology systems. Thank you.